We'll begin 9.2. Turns out 9.2 is one of the more difficult sections in the chapter for most students. So I want to begin with some review. We're just going to ease into this as gently as possible. Let's start with something like x plus 3 squared, if we wanted to multiply that out. So, okay, if I've got a quantity squared, that means I'll need to do x plus 3 times x plus 3. And then I'll need to FOIL. Right, so if I go first times first, outside, outside, inside times inside, last times last, and we're probably, hopefully getting more comfortable with this sort of thing. X squared plus 3x plus 3x plus 9, we can combine those middle terms and arrive at that, x squared plus 6x plus 9. What we want to take away from this is that right there, that x squared plus 6x plus 9 equals x plus 3 squared. And okay, it's probably, nothing, probably not really pushing your abilities here, but that's okay. This is a big deal. Just the fact that, the nature of the relationship here, there's some, okay, anyway, we got it. I also would like to look at the subtracting case, x minus 3 squared. Well, we can go about it the same way. Let's call that x minus 3, x minus 3. Then we'll need to FOIL, like so. And we'll combine those terms in the middle. This time it's x squared minus 6x plus 9, and that's what I'm going to write out over here, equal to our first line, x minus 3 squared. Again, probably not pushing your skill abilities here, but that's okay. We're easing in as gently as we can. Okay, so then you ask, all right, well, what's this section all about? Why is it so hard? It doesn't seem so bad so far. It's called solving by completing the square. Completing the square in its own right is a very, very handy algebraic tool that comes up every once in a while, even as far as as high up as you go in math. Occasionally, be like, oh my gosh, what do I even do in this position? And somebody will say, oh, we should complete the square. Like, oh, okay, so we're going to learn this in the specific context of solving quadratic equations. But there's kind of a bigger story to it, but kind of giving you a little bit of background. So the big idea is this. We've got these two formulas, and we saw specific cases. I'm trying to see if I can fit this all on the screen at once. Okay. We saw these for specific values of y when y was 3, but in general, x squared plus 2xy plus y squared equals x plus y quantity squared, and x squared minus 2xy plus y squared equals x minus y quantity squared. These are referred to as the perfect square trinomials, and that name comes from, well, the trinomial, because there are 3 terms here on the left, and it's a perfect square because it factors just so perfectly as x plus y squared and x minus y squared. Okay, so we're going to take advantage of these equalities in this idea of completing the square. So what is this all about? Again, we're actually still easing into this gently before we get to our first example of solving. we're going to, for this example, we're going to fill in the blanks to form a perfect square trinomial. So what do I mean? Oh, and it looks like I already had these blanks filled in. From doing it myself, I need to go back and erase some things here on my page. I apologize. Quite a few examples I'm cleaning up here. Okay, think. All right, now I'm ready to show you. What if we saw x squared plus 10x plus blank equals the quantity x plus blank squared? How would we fill in these blanks to form a perfect square trinomial? And really a question like that, I'd much prefer to be in the room with you guys and let you think about it. And I wouldn't be surprised if one or two people at least saw it pretty quickly. If I've got x squared plus 10x, what would go here to make this perfect square trinomial? And it turns out that it's 25. And if you're having trouble seeing that, what's going on? Okay, so well, it's the first equation, right? So I've got my x squared, I can see that. Then the second part is 2xy. But I don't see 2xy, I see 10x. Well, what must have been the value of y? What was y so that after I simplified it became 10x? Didn't y have to be 5? 2 times x times 5? And the 2 and the 5 would make the 10? And if we can see that, well, then that same 5 is going to go over here and become 5 squared, and there's my 25. But I wouldn't be surprised if some people didn't really even have to think that hard about it if they knew almost intuitively, oh, x squared plus 10x, if you were to FOIL, that would have come from 5x plus 5x, and the 5 squared would go here, and there's, okay. So there's the first blank. How about this second blank? And I bet this second blank will be easier now that we've talked about the first one. If that's a 25, what has to go here? And well, if we compare to the formula, or maybe we just know intuitively, that's got to be the 5, right? So if we were to FOIL this side here, multiply it all out, we would get exactly that right there. Or you could think of it, if we were to factor this, it would become this guy right here. If that's still difficult to see, then there's some patterns going on here. So let me point out what's happening. I left some space here to explain how we can get these numbers in this case, or even a more difficult case. Here's how we get this first blank. Take the number in the middle, divide it in half. So take 10 divided by 2, whatever that result is, square it. So I took that middle number, divided it in half, and then squared it. So that gave me 5 squared. That's my 25. And then over here on this side, well, it's somewhat like, what is the 5? And it's like, if I know that's 25, then the square root is going to be this number. Or maybe I just think of it, what was it before I squared, right? So it was just the 10 over 2. That's what, maybe I just say it's like half that middle number. You know, that was that, which was the 10 divided by 2 in the first place. Okay, let's do another one. See if you guys got the rhythm here. How about this? X squared minus 6x plus what equals the quantity x minus what squared? And one thing you notice, we've got the minus going on. The minus here will mean there's also a minus sign there. What should this number be? And we can follow the same pattern. And maybe some of you are thinking to yourself, you know what it is. Others are like, what? Not really sure. Well, hey, if this is a 6, let's follow the same pattern. We'll take that number, divide it in half, and then square it. So if we take 6 divided in half, we get 3. 3 squared. This number must be 9. And what is it going to be on this side? X minus what? Well, it's whatever the number was before we squared. And so for us, of course, that was 3. So I didn't leave any space to make any notes here. Same idea. 6 divided by 2 squared. And this was just the 6 divided by 2. Okay, I've got one more for us. And I will warn you, they get more difficult. This is the hardest one of the 3. X squared minus 7x plus what? X minus what squared? And we think, oh my gosh, you know, these two were much easier because they were even, right? 10 divided by 2 is 5, 6 divided by 2 is 3, but 7, if I'm going to follow that same thinking, I'm really not sure. But okay, well, let's do it. What's going to go here? Same pattern. I'm going to take that number divided by 2 and then squared. Well, it does not come out to a nice answer here. And maybe some of you are tempted to make that a decimal, 3.5. Let me encourage you, please keep the fraction. Where this is going to go further in this section in the next videos, you got to leave this as a fraction. There's no choice. So 7 over 2 squared, and you might recognize, oh, so I just square the top, and I square the bottom. That's going to be 49 over 4. And a lot of us like cringe at this. We've got this like ugly fraction. Yep, that's the way it is. There's no way around it. And you do want the fraction. You do not want the decimal. But hey, you know what? If you follow the same pattern, what's the big deal, right? Divide it in 2, square it. Divide it in 2, square it. Divide it in 2, square. Okay, it's a fraction, but, you know, we can work with that. And then the question becomes, what's this number here in the second blank? And, well, we just take it what it was before we squared, so we're going to say that's 7 over 2. And there you go. Okay, let's stop this video here. I think we've got the completing the square examples now. We're going to be ready for them. We've practiced enough. I know this last example usually is very challenging for students, but you know, just kind of remember that pattern, right? Divide it in half and square it. Divide it in half and square it. Divide it in half and square it. All right, I'll see you in part 2.